This is A2 Pure Mathematics. We're looking at some CCEA past paper questions. This one's from C4 January 2014. Question 8. A paperweight can be modelled as a solid formed when the area bounded by the curve y equals root ln x over x. The x-axis on the line y equals 5 is rotated through 2 pi radians about the x-axis. Find the exact volume of the paperweight. We need to be careful here, and some people are going to miss this step. But if you know what the graph of y equals ln x looks like, you need to be careful with this one. So we need to work out where this one actually crosses the x-axis. So the first thing I'm going to do is work out where it crosses the x-axis. And you do that by putting y equal to 0. So if you put y equal to 0, you're going to get 0 equal to root ln x. I'm not sure what I think I've written there. So this would be ln x over x times through then by x. So I get 0 equals root ln x if you want to square both sides, but either way it's going to give you x equals 1 because ln 1 of course gives you 0. So we know whenever y equals 0, x equals 1. That means it actually crosses the axis at that point. I'm not even quite sure what this graph here looks like, but I know the graph of ln x, and you should too know that that one looks like that, and that one crosses at 1. So it was just being careful there, and then we were kind of going to do it up to 5. Now it isn't quite the right graph, but you kind of get the idea, and then we're going to rotate that one around. So at least that's us started. Let's look at our formula then for volume. So volume, of course, is going to be pi between 5 and 1 of y squared dx. So in this case 5 and 1, and we square this. So obviously you square the top line, you're going to get ln x, and square the bottom line, you would get x squared dx. Again, a couple of ways to deal with this one. I'm going to try and do integration by parts here, and we'll see how I go. So if you maybe consider the integral between 5 and 1 of 1 over x squared upon ln x, then those are going to be my two parts. So I'm going to have u equals ln x. Remember, if it's an ln x, isn't it, you normally get u equal to it. And then dv by dx is 1 over x squared, or if you want x to the minus 2, du by dx is 1 over x, and then v, if you integrate that, so you would add 1 to the power to get me minus 1, and then divide by minus 1, so it's going to be minus 1 over x. That means my volume is going to be pi uv, so it's minus 1 over x ln x. I'm going to keep that wee bit separate. 5 and 1. Take away the integral of v du by dx. So that's a minus, so I can change that then to a plus, and it's 1 over x times 1 over x dx. And integrating that then, we've just kind of done it because we've just integrated a 1 over x squared, so that's nice and straightforward for us. It's going to give us a minus 1 over x. So this then all becomes minus 1 over x ln x, and then integrating this gives me minus 1 over x. That's all between 5 and 1, and we're almost there. So volume then is going to be pi upon, let me see if I can work this out, so it's minus 1 over 5 ln 5, take away 1 over 5 minus 1 over 1 ln 1, take away 1 over 1. So how are we going to tidy this up then? Let's take a wee look. So we'll get volume equals pi minus a fifth ln 5, and then we've take away a fifth plus 1 effectively is what we have there. Now note ln 1 just gives you 0, so that bit disappears. So hopefully you see what I've done there. So it's a minus and minus, that's just a 1, so it's minus a fifth plus 1, so effectively then going to be plus 4 fifths. There's a fifth there and a fifth there. You may want to take it out the front, but other than that I think we're okay. So that's that in terms of our units squared.